Hi everyone, welcome back. In this lecture, we are going to understand the important features of the Spring framework. These features are what make Spring one of the most widely used frameworks in the Java world. We will go step by step and I will explain everything with simple real-life examples, so even if you are completely new to Spring, you will understand it clearly. The first and most important feature of Spring is dependency injection, also known as DI. Dependency injection simply means your classes do not create the objects they depend on. Spring creates them and provides them for you. Let me give you a simple real-life example. Imagine you are driving a car. You do not build the engine yourself. You simply say, I need a car, and the manufacturer already provides the car with the engine installed. The engine is a dependency. The manufacturer is Spring. You are the class that needs something. In other words, Spring supplies what your class needs instead of your class making it. So, dependency injection means that your classes do not create the objects they need. Instead, Spring creates those objects for you and injects them where required. This removes the need to use the new keyword everywhere. This makes your code cleaner, more organized, and easy to test. The second feature is inversion of control, or IOC. Normally in Java, your code is responsible for creating objects and calling their methods, but in Spring, that control is inverted. The Spring framework controls object creation and management. Think of Spring like a kitchen chef. You simply place an order, I need this object, and Spring prepares it, manages it, and gives it to you. Your code does not control object creation anymore. Spring does. This is why it is called inversion of control. Next is the bean management. The objects that Spring creates are called beans. Spring stores and manages these beans inside something called the Spring container. You can think of the Spring container like a warehouse. All your important objects are stored inside this warehouse, and whenever your application needs one, Spring will deliver it. This means you don't worry about how objects are created or how long they should exist. Spring manages everything. Next is annotation-based configuration. Earlier, Spring required large XML configuration files, but today we use simple annotations. Annotations like @component, @service, @repository, and @autowired tell Spring which classes to manage and where to inject dependencies. This makes Spring development much faster, cleaner, and easier. Another big advantage of Spring is loose coupling. Loose coupling means that objects depend on interfaces, not concrete classes. For example, if your application needs to send notifications, it can depend on a notification service interface, not on a specific implementation like email or SMS. Later, if the company decides we no longer want SMS, we want WhatsApp notifications, you just change the implementation, not the entire application. This flexibility is why Spring is used in enterprise-level applications. Next is it makes unit testing easy. Since Spring provides dependencies automatically, we can easily replace real objects with mock objects during testing. This means unit testing becomes faster and cleaner. You don't have to modify your application logic just to test it. Spring naturally supports testing workflows. Next, centralized and consistent configuration. Spring allows you to keep all your configuration in one place. Whether it is database, settings, service wiring, or environment-specific values, Spring provides a central configuration approach so your project remains organized and easy to manage. Next is lightweight and modular. Even though Spring can do a lot, it is still lightweight and modular. This means you only use the parts that your application actually needs. You do not have to load the entire framework. For example, if you only need dependency injection, you can use Spring Core and ignore everything else. This makes your application efficient and optimized. Next is declarative support. Spring allows you to enable features like transactions, caching, security, just by using simple annotations. For example, instead of writing complex code to manage transactions, you can simply add transactional and Spring will handle commit and rollback logic automatically. This reduces repetitive code and avoids bugs. Let's quickly summarize the important features of the Spring framework. Dependency injection. Spring provides required objects automatically. Inversion of control. Spring controls object creation instead of your code. Bin management. Spring stores and manages objects in the Spring container. Annotation-based configuration. No XML, simple and clean annotations. Loose coupling. Easy to change implementations without breaking code. Easy testing. Mocks can be injected easily. Centralized configuration keeps your application organized. Lightweight and modular. Use only what you need, nothing extra. Declarative support. Use annotations to enable key features like transactions, caching, and security. Spring focuses on helping developers write business logic, while Spring handles the complex setup, wiring, and lifecycle work behind the scenes. This is what makes Spring so powerful, flexible, and widely used. Alright, that's all for this lecture. I'll see you in the next lecture.